Hello my dear friends, welcome to our program for Science third purpose stage. Today we have an important session about revision unit 1. We have many examples, we have many problems, we have many types of questions to revise it and study it many times in your books. Let's start our session today and concentrate with me very well. Let's start. So we have the revision of unit 1 about the speed, acceleration and many types of them. So the first of all, we have the speed again. It means the measuring of how far the object moves in the given time. And we have the second one, we have the speed. It's the change of distance in unit time. I need to know this expression, the speed and acceleration and many one of them. Let's start our part here about problems. Problems here is very important for us. First of all, also we have the formula triangle to make speed rule. So we have this triangle, it's like this. I need to know the speed. I revise with you. I have a speed equal distance divide time. And if I need to calculate the time, we have distance divide the speed. And the last one we have, if I need to calculate the distance, I need to calculate S times time, speed times time. And we have the symbols of S, it means speed, or V, it means velocity also, or speed. Let's go to C. Another one of these problems, a special car can move from rest and its speed reaches 90 meters per second in 10 seconds. What is the acceleration with which the car moved? This car, it has the first one, or it has a speed and it moves in a time interval. So we have the answer is A equal V divide T equal 90 divide 10 equal 9 meters per second square. Let's go to see another one. On a straight line there are moving bus. Its speed change from 6 meters per second to 12 meters per second. Concentrate with me very well here. We have a bus that move from 6 meters per second to 12 meters per second during period of 3 seconds. So we have 2 speed and we have 3 seconds like this. What is the amount of acceleration? Calculate the acceleration. I have here we have two speed, 2 values of speed. So we have 12 and 6. The first one all the time it's the initial speed and the second one is final speed. So we have 12 minus 6 equal what? Equal 6. So the acceleration v2 minus v1 divide t, and we have this 12 minus 6 divide 3 equal what? Equal 2 meters per second square. Why? Because 6 divide 3 equal 2 meters per second square. This is about acceleration and about this problem here. Another one. If an object moves from rest, concentrate very well, from rest it means from 0, so the initial speed is 0 regularly until its speed reaches 10 meters per second after 10 seconds from start to move or moving therefore. So we have many parts like this. We have many questions about this problem. The change of speed through 2 seconds equal what? Equal 10 meters per second. So we have this one, this is in 2 seconds, so 20 divided 2 equal 10. And we have the change of speed through what? Through 1 second equal what? Equal this one. We have this part 10 divide 2 equal 5 meters per second. So here we have this acceleration equal what? Equal 10 divide 2 equal 5 meters per second square. Don't forget meter per second square as a measuring unit of what? Of acceleration. Another one. Write scientific term. It's very important for you to find out the meaning of each sentences here. Okay, sentence, it needs one rule or one concept, one scientific term. The first one, the rate of a change in displacement relative to time. So displacement relative to time or relative to time, it means what? It means velocity. Why? Because here we have displacement and what? And relative of time. So we have time and displacement, so we have velocity. If I have distance and time, we have speed. Or if I have speed and time, it means acceleration. Another one, the distance covered in unit time. So this one is Very easy, it's speed, right? After that, we have the actual pass. It's the key word here, actual pass, that covered by a moving body. It means what? It means distance. It is not displacement. Why, mister? Because we have the displacement needs the direction. It doesn't need direction, so we have the distance. It doesn't need direction because it is a scalar quantity. Another one, shortest straight line that covered by a moving body in a direction or in one direction or indefinite direction. So the shortest straight line, it means what? It means displacement. Another one, physical quantity that needs magnitude only to be identified. So the physical quantity that needs magnitude only to be identified. Which one? It's a scalar quantity, right? If you need to write scalar physical quantity is right, but don't write just only scalar. It's a scalar. What scalar? What is the scalar? Scalar quantity, scalar physical quantity is right. So the physical quantity that needs magnitude only to be identified, it is a scalar quantity. Physical quantity that needs magnitude and direction to be identified. So it is vector 1, vector quantity. Like what? Like force, like energy, like displacement, like velocity, acceleration, any one of them. So here we have another type of question that calculation of speed. So calculation of speed, how can speed represented? So we have this one, it's the first one here. We have this activity to make what? To make the relation between distance and time. Every time we have different distance and we have different time. So the speedometer that found here in our slide here increases or show us increasing of speed, increasing in time, increasing of distance here during time. So it reaches about 110 meter per second or kilometer per hour. So here meter and seconds. So it reaches what? It reaches 80, 90, first 80, 70, 60, and we have 50, 40, and so on to reach what? To reach 0 or to make the car stop. So we have many distances that covered here. 994 in 50 seconds, and we have another one 994 in 55 seconds, and we have also 994 in 60 seconds. So we have next like this to find out the table or tabulate these parts or tabulate these numbers in distance time cells. So how can the speed represent? The data can be recorded at the shown in the table. Don't forget this. You need the tables, you need graphs, you need many things about the speed and the acceleration or anything like this. Data can also be shown in the graph. What is an advantage of this one? The advantage here, it means what? It means I can draw a graph and with a gradient like this to represent what? To represent the speed. This part or this speed represented by what? By these parts. We have curved line, we have straight line, we have uniform speed, non-uniform speed, to know the relation between them. After that, we have speed graph. This, how can you calculate the speed or distance time graph here? We have this one, the speed shown in this distance time graph. How can you calculate it? From the gradient, from slope, we have 8 divide 8, it's 1 meter per second. After that, next, we have another one. We have this 8 divide 4. It means what? It means 2 meter per second, right? Why? Because here we have the first one, the slope here, it's 8. 8, it means what? It means this part, it's called, it's 8 here, or equal 8. It's y-axis or distance axis by meter. And the second one from 0 to what? To 4. It is the second one. Here, this is what? This is second, and the x-axis or time axis, this is the second part. 8 divide 4 equal 2 meter per second. Next one, you have this part like this, like the first one. Here we have 4, and here we have 8 seconds. 4 meters divide 8 seconds. It's equal what? 0.5 meter per second. Very good. Next, this one equal what? Equal 5 meter per second? No way. it's 1 meter per second? No way. 8? No way. Because what? Because we have no motion here. 0 meter per second. Thank you very much. So the distance time graph also. Distance time here. If I have this A, it's 0 and 0. Try to make your own one like this. First one, 20 and 2. And we have C, it's 30, or what? Or like this, 30 and 3. And we have 4 and 40. And we have 5 here like this, and 50. And the last one is F like this. We have 3. It's 60 and 6. It means what? It means these points here, they represent what? Represent one straight line from 0 point, from original point. That represents what? Represent the uniform speed. Uniform speed, it means increasing the speed during time, each point. But if I have this part like this A, it's here, if A here, it is the first one. And if I have this part like this, B, C, and we have another one, we have D, and after that we have E, and after that we have F like this. So we have this is a straight line, represents what? From B to F, it means what? It means the body at rest. But if I have this one like this, F is here and E is here like this, for example, and we have D, and we have D, and we have here, this is the C like this, increasing, decreasing, increasing, and stop. This is called what? This is called zigzag line, or in some cases we have curved line. This curved line represents what? Represent distance time graph. It means what? It means non-uniform speed. And we have many things about this. So this is about what? About distance and time. After that, we have problems also. In another case, we have a speed here, represent the speed. Start this one. A bird flies 10 meters in 2 seconds. What is the speed? 10 meters in 2 seconds. 10 divided 2 equal what? Equal 5 meters per second, right? So this is very easy one. And don't forget this one, because the easiest problem comes out from the examples in your books, and you cannot answer it in a right way. Concentrate very well and study the examples like what's like the exercise in the last part of your books. Question number 2, if an airplane that takes 8 hours to fly 5,000 kilometers, what is the speed? So it takes 8 hours and 5,000 kilometers. So here is 5,000 kilometers divide 8 hours. I need here kilometer per hours. So here this is what? This is 600. Okay, 25 kilometers per hour. This is right. Why? Because 5,000 kilometers divide 8 hours. So next, a man takes his dog to the vet, and who is 30 kilometers away. If it takes him 45 minutes, what's the speed? So kilometer and minute, we must change one of them. 45 minutes, it means 0.75 hour. Or if I change the minutes and change the kilometer into meter and seconds, but here I need to kilometer to hour. So which one of them? So here 0.7, no way. So we have here 1.5, no way. This is 40 kilometers per hour. So the distance divided the time, 30 divide 0.75, 45 minutes change into 0.75 hour. So it is 40 kilometers per hour. Next one, we have a woman walks at 5 kilometers per hour, the speed, in 30 minutes. So I change these minutes into hours. This is 0.5. So the speed times time gives what? Gives the distance. So 5 times 0.5 equal what? Equal 2.5 kilometer. So the speed equal distance divide time. The speed times time equal 5 times 0.5, 30 minutes, change into half an hour. change it into another one. Number 5, we have how long does it take the lorry traveling at 10 meters per second to cover 1 kilometer. 1 kilometer, it must change into meters, so it is 1,000 meters. 1,000 meters distance times the speed, or speed divide the distance to find out the time. Speed divide the distance, so it is what is 0.1 second here. This is wrong, and we have 100 second is right. Why? Because we have 1,000 divide 10. It's what distance divide time, and the time equal distance divide the speed. So the 1,000 divide 10. 1 kilometer equal 1,000 meters. Don't forget this changeable, or this units and the change between them. Next one, we have a snail moves at 0.03 kilometer per hour. It's very, very slow one. How long does it take the slime its way 1 meter along a garden path? So again, we have this is the speed, and we have the distance. Speed times distance to find the time, or time taken. How does it takes? It needs the time. Time, it means what? It needs speed divide distance. So here we have speed. It means 0.3 kilometer per hour in 1 meter. Here it means what? I put it on the kilometer. This is 0.03 minutes. No way. It's 1 minute. No way. It's 33. No way. It's 2 minutes. Why? Because here we have distance divide time equal time, or time equal distance times the speed, or divide the speed. 1 divide 0.5. 0.3 kilometer per hour equal 30 meter per hour, or 0 meter per minute. So I need it by minutes, or I need it by what? By seconds, or anything like this. We have another problem here. This problem is about the runner. Runner curved or covered the distance of 100 meters of a straight track in 10 seconds. Then he turned it back walking. Walking, it means more slower than the running. So it takes longer time. The first one takes running 10 seconds, and the second one take the same track in 80 seconds because he was walking. So we return it back to the rest point. Complete the following. We have many questions about it. His average speed while running is what? Is 100 divide 10 equal 10 meter per second. Why? Because we have distance that covered by this runner is 100 meters. He took this distance in 10 seconds. After that, we have his average speed during returning back equal what? Equal 100 divide 80. It's equal 1.25 meter per second. This is very slow one. So here, after that, we have another part of this problem. His average speed during a trip, during a whole trip. It means what? Total distance divide total time equal 100 plus 100 divide 80 plus 10. It means average speed. Average, it means total distance divide the total time. It's equal 2.22 meter per second. Calculate the speed of the runner if he's covered the distance of 100 meter in 20 seconds. So we have 100 meter in 20 seconds, so it is what? It's the 5 meter per second. Why? Because here they calculate the speed of the runner if he's covered distance 100 meter in 20 seconds in another time, in different time. So we have 10 divide 20, or 100 divide 20 equal 5 meter per second. This part about acceleration problem. So we have start. Acceleration first equal change in speed divide the time. So let's start here. We have the car increases in speed from 10 meter per second to 20 meter per second in 10 seconds. What's meant by this? We have two speeds here. 20 is the final one. 10 it is the initial one. So this one is the V1 and this one is V2, the second one. So what is the acceleration? 20 minus 10 divide 10 equal what? Equal 1 meter per second square. Why? Because the acceleration changed the speed in the time. 10 divided 10 equal 1 meter per second. We have next. Question 2. A bike traveling at 30 meter per second shows down to, or slows down to stop in 15 seconds. So what is the acceleration here? 30 divide 15 equal what? Equal 2. It's 2 is right. It is wrong. Why? Because here we have a slows down. Slows down, it means negative 2 meter per second square. Next. Question number 3. A cyclist set off from rest and accelerate at 0.2 meter per second square for 30 seconds. What is the final speed? So the final speed is what? 6 meter per second? Yes, it's right. Because the change of speed in time, it means acceleration. And the change in speed, acceleration times time equals 0.2 as an acceleration. Times what? Time the second, or times time, it's equal 30 seconds. So it is 6 meter per second. Next. The space shuttle accelerate at 30 meter per second square at lift off. How long does it take to reach 1,800 meter per second? So 4 minutes, 3 minutes, 2 minutes, 1 minute. 1 minute is right because we have the acceleration. It's 1,800 divided 30 equals 60 seconds. I need it by minutes here. Here we have another one. A car traveling at 2 meter per second accelerates at rate of 0.5 meter per second for 20 seconds. What is the final speed? So we have 10 or 12. Yes, 12 is right because it changed the speed by the time. Change in speed, acceleration times time. So we have 0.5 times 20 equal 10 meter per second, and final velocity it's 12 meter per second. So we have a very important part to revise. It's the relative speed. So we have the relative speed. Again, we have two passes like this. Concentrate this one because it is very important one. Relative speed, it's like the two passes here. They move in one direction with the same speed, the same time, the same distance. So we have the uniform speed. So the first one moves by 20 km per hour and 20 km per hour for the second one. So here I need to calculate the relative speed between them. If I write the first one, I need to know the speed related to me from the second one. So here we have it's if two cars move in the street in the same speed and the same direction, they appear constant cars for each other or constant object for each other. The second case here, so we have the relative speed equal v1 minus v2 equals 0. 20 minus 20 equals 0. So the second case about this one, relative speed, we have two cars or two passes like this that move in the same direction with the same speed. No way. One of them is much faster than the other like this. So we have this one, it's 10 km per hour for the slower and 20 km per hour for the fastest one. So I need to know that relative speed between them. So it is v1 minus v2 also because they have the same direction. So the same direction we use minus, we use negative, okay? So v1 minus v2 equal 10, 20 minus 10 equal 10. So 10 meter per second. So the two cars moved in the street with a different speed in the same direction. The first car appears more faster than the second car. But in the second car, if I have this case, the second car appears to the first car more slower. Why? Because I need to calculate the relative speed for the first car to the second car, or second car to the first car. It's also like this. So after that we have the third case. If I have these parts, we have the street and we have two buses or two cars like this in the opposite direction as we have now. So relative speed between them, it has two different or two similar speed. It is not important because they have the different direction. So 10 km per hour and 20 km per hour. what is the relative speed of each one of them to the other one? 20 plus 10. So if I have two equal speed, 20 and 20, we have 20 plus 20 equal what? Equal 40. So the first one and the second one, we have relative speed between them like this to make what? To make the summation of what? Of the two speeds here that change or that make the relation between them or relative speed from the first car to the second car or vice versa, 30 kilometers per hour. 30 kilometers per hour, it means what? It means plus each other. Two speed plus each other. Because what? Because we have the two cars that move in the street with a different speed in the different direction. The first car appears more faster than the second car because we have the second car is more faster or what? Or the summation. Dear friends, I hope to enjoy your time with us. We have many questions to revise. We have many lessons to study and to revise it many times. Till we meet again in another session of Science Third Prep Stage. Till we meet again, thank you. Goodbye, everybody.